Am I audible? Okay. A warm welcome to one and all join with us. We, the Department of Computer Science, is organizing the 12th session of the webinar, Sensors and Transducers. Today's session will be handled by Mr. Jayakannan, Assistant Professor, Department of Mechatronics, Jyothi Engineering College. Once again, I welcome you all to the session. Now, I invite a resource person to handle the session. Welcome, sir.
Thank you, madam. So, good afternoon to one and all students. So, myself, Jayakannan, I am working as the assistant professor in Mechatronics Department, Jyothi Engineering College, Thrissur. Am I audible? Is it okay? Is it audible? Yes, fine. So, actually, you had the wonderful session for the past 3 or 4 days. So, you people have started learning about some physical parameters, measurements like pressure, level, and today it's the session for flow. So basically, before entering into any measurement, we should know some basics about measurement. Okay. So I want today's session should be like interactive session, not like I'm only talking for 1 hour and you people are listening. So better whatever the basics which you learned already, you just share with me. Okay. So now the thing is that whenever we are measuring any physical parameter, the measurement takes place an important role. Can anyone say what is measurement? Definition for measurement? Anything can be tell in this forum. What is measurement? Any student can answer. What is the definition for measurement? Any idea? Sir, the question is clear, right? Sir, is it audible? Yes. Yes. What is measurement? Why we are going for measurement? Whatever the answers you know, you just share with me. No issues. The unit of measuring certain quantities or determining the size or magnitude of something. Yeah, someone have messaged. The thing is that before entering into any type of measurement, we should know these things. So like what is measurement, what is the need for measurement, and what is a sensor, and what is transducer, and what is meant by physical parameter and electrical parameter. So before entering into any measurement, it may be a flow or temperature or pressure or anything maybe. So the basic thing is measurement. So measurement is nothing but measuring a physical quantity or any quantity to a certain level so that we can process accordingly. And what is the need for measurement? So thing is that why we need measurement. So without measuring, what is there? And after the measurement, what is there? So the need for measurement is nothing but when you want to specify any quantity in certain level or any certain amount, you need measurement. Okay. So after measuring that quantity and how you are measuring. So before measurement, you need to know about what is sensors and what is transducer. These are all the main two parameters or two components which will be used for all the types of measurement. Okay. So next thing is sensors. Can anyone say what is sensors? Have you heard the word sensors? Now sensors plays an important role here, everywhere. In every mechanism, sensors plays an important role in sensing any physical quantity. Okay, so sensors is nothing but sensing a physical quantity for measurement. Okay, sensor is the basic term which meant for sensing any physical quantity. Okay, so the next is transducers. So there is some difference between sensors and transducer. Transducer is a device which converts one form of physical quantity into another form. The mostly the another form will be like electrical form. So if you want to sense a pressure, or else if you take a pressure sensor, the input will be pressure. Okay, so you are converting those pressure into your electrical output. So there we required one transducer. So sensor part is sensing, it just senses the physical quantity, then it is over. But in the transducer part, after the sensors, if you want to convert that physical quantity into electrical quantity, then we require one transducer. Okay, that is the main difference between sensor and transducer. Everywhere if you go, when you study sensors and transducer, the first question will be asked in any interview is what is sensor and what is the difference between sensor and transducer. Even it may be after your graduation, when you go to your company for interview or anything which is related to any mechanical or electrical industry, they will surely ask you this question: what is sensor, or what is transducer, or what is the difference between both? Okay, I'll clearly explain that the sensor is a device which senses any physical quantity. Okay, and transducer is a device which converts those physical quantity into electrical quantity. Okay, this is the main difference between a sensor and transducer. Can you name any example of a sensors? Anyone? Can you name some sensors? Examples? You can switch on your mic and you can answer it. No issues. Anyone say some examples of sensors which we are real time we are using nowadays? Many sensors we are using. In day-to-day life, we are crossing so much of sensors. Okay?
Automatic gate system.
Yeah.
We are using some type of sensors.
Okay, whenever a person is crossing the gate will be open automatically and it will be closing automatically. Yes, ma'am. Yes, you rightly said the sensors plays an important role even in the automatic door system. Even nowadays, it will be available in our buses also. So when a sensor or an obstacle, okay, so whenever there is an obstacle is passing towards the both sides of the sensor leads will get output and it will open the door automatically. Okay, so this is type of a sensor which we are using. And next comes the part transducers. Even we are using some thermometer, basic thermometer or basic thermometer is a transducer. Okay, because which we convert the physical quantity, that is heat, into your readings. That's why we are having some digital thermometers also nowadays. Whenever we are insert the thermometer, immediately after 20 seconds or 30 seconds you are getting the output. So it is like a digital thermometer which we are using in the hospitals nowadays. Okay, so from that point of view of transducers, we can come to know that what is physical parameter and what is electrical parameters. Okay, so the physical parameter is nothing but the physical quantity which will be like pressure, temperature, flow. These are all called physical parameters. It is not relevant with any electricity. Okay, the physical parameter is nothing but the temperature, pressure, flow. These are all the physical parameters, that is physical quantity. And what is electrical parameter is nothing but your voltage, current, okay, power, velocity, everything which is coming under electrical parameters. So we should know about the difference between what is physical parameter and what is electrical parameters. Okay, so these are all the basics behind why we are learning this subject. Okay, so the next thing we can go directly to our syllabus. That is the topic which given to me is flow measurement. And this is also we have to ask the same question: what is the need of flow measurement? What is the sensors used in flow measurement? Okay, these are all the common questions. That's why I have given in the preface. For every measurement, you should know the basics. What is the need for those measurements? Okay. Okay. Anybody tell me what is the need for measuring flow?
To control overflow or
To
something.
I think it's not audible. Can you tell me?
Overflow to check on.
Yeah, if you want to check a level, or if you want to check flow in a pipe, or if any obstacles is present in that, we are going for flow measurement. And mainly nowadays the flow of water or flow of oils and flow of gases, everything is coming into picture. If you take any industry, say for example, if you take a cement industry, the raw material will go from one place to another place because everything is 100% automatic. We are not going doing the manual. The raw material which is kept in one place, which will be moved by using one conveyor belt. I think in most of the videos you can see that the raw materials or any particles or any materials which will be moving from one section to another section by using one conveyor belt. There requires some measurement. If you want to measure the flow of some particles or some liquid or whatever it may be the particles, may be the liquid or solid or anything, or it may be a gas. Gas flow measurement is also there. So we can measure three types. We can measure either solid flow, we can measure liquid flow, and we can measure gas flow. Okay, so we can measure all the three. These all the three coming under the measurement of flow. It will be used readily in the all industrial environments. Okay, so this is the need of flow measurement. And when flow measurements come into the picture, the main parameter or main device which comes into our mind is venturimeter. Okay, venturimeter is a device or a component which is used for measuring the rate of any flow of liquids. If any pipe, if you consider one pipe where the water is flowing, okay, say for example in your home also, we have in mostly in Kerala, I don't find any pipes there for home water distribution. But when we consider Tamil Nadu and some other states, like every home is having some pipe. Okay, they will give some drinking water through that pipe only, and they have some meter in their street also. They will measure the flow of what is the rate of flow of the liquid through the pipes. And in when we consider some industry environment, that also they will measure all the flow of liquids. Okay, so whenever there is a measurement for the rate of flow of liquid, this venturimeter is a device which is used for measuring that. Okay, so before going into venturimeter, we have to know some basics about Bernoulli's equation or Bernoulli's principle. Okay, so the basic principle which is the venturimeter is working is called as Bernoulli's equation. So what Bernoulli's equation is telling, that we have to know. Before knowing that, we have to know, actually this is like a step-by-step process. Once you know one concept, you have to know the basics of that concept. So before that, like that, it will be going on. So the Bernoulli's equation, in simple, we can say is this. We can say that there will be some energy is there. Whatever the flow will be there, whenever if you want to move one place to another place, some energy will be needed. For example, when we want to move from one place to another place, our body requires some energy. So it seems that whenever there is a particle or any movement, some energy will be moving from one place to another place. Okay, so they are naming it as two energies. One is potential energy and another one is kinetic energy. Okay, so the potential energy is nothing but when the energy which is created when the object which is in stationary mode. Okay, so then it is called as potential energy. The kinetic energy is nothing but the energy which is used for moving the object from one place to another place. So what Bernoulli's equation is telling, that Bernoulli's equation is relating three types of energy: pressure energy, kinetic energy, and potential energy. Okay, so the three energies they are taking in one liquid. So for example, in right side you can see one diagram where the liquid is flowing from one direction to another direction, and in between the radius or width of the pipe will be reduced actually. So what they are mean to say is, when there is one big pipe, okay, the water is flowing in certain energy, and when the pipe is diverged for some extent, maybe diverged into small area, then once again it is converged to the original size. Then they are comparing the flaws between before this entry of this small area and after the entry of this small area. They are calculating and they are equating this both. Okay, that is behind your Bernoulli's equation. So basic terms behind your Bernoulli equation is, first one is flow rate. Okay, so the flow rate is nothing but velocity of the fluid which passes through the given area. So it seems that what is the velocity of the liquid? Okay, velocity is nothing but there is one movement from one place to another place with one direction. Okay, so the velocity of the fluid which passes through the given area, then we can say it as flow rate. And another one is volumetric flow. So the volumetric flow is nothing but volume of the fluid traveled through a cross-sectional area. Both are same. Actually, in a corresponding area, how many flow is going and how many flow is coming out. Okay, these are all the terms behind your venturimeter. And that conduit is a term which is related to the shape of the container. Okay, because when you flow a liquid in a pipe, the direction and the area which will be different, and if you increase the pipe size, the flow will be easily increased or decreased. Say for example, your pipe will be very small, then the flow will be very high. When you increase the pipe size, your flow will be decreasing because the area is increasing. That's why your flow is decreasing. So that is inversely proportional. So the size or shape of the path of the fluid is also an important one for venturimeter. Okay, so the thing is that when we consider the flows, the flow will be like two types. First one is turbulent flow and second one is laminar flow. Can you find any difference in diagram? From diagram, how you are seeing?
In turbulent, it is not uniform.
Okay.
But in laminar, it occurs a specific shape.
Yeah, very good. So in turbulent flow, the fluid undergoes some irregular fluctuation. Say for example, it is like a discontinuous flow. The flow is not continuous, it will be going upwards and it will be going towards. So by measuring some flow, which is best? Laminar flow is best or turbulent flow is best? For easy measuring of flow, which one is best?
Laminar.
Yeah, laminar has some regular fluctuations and there is no disturbances in the flow. So it will be going automatically. So we can easily measure the laminar flows. So what you have to do is, if any turbulent flow is there in your pipe in industry, you have to convert the turbulent flow into laminar flow in between. Okay. Next one is, as I said in Bernoulli's equation, this is the common diagram for Bernoulli's equation. So in the left side, we are having one pressure, velocity, and those area. What Bernoulli's theorem is telling that before the restriction, whatever the pressure and area and velocity which is there, which will be equal to the pressure and area and velocity after the convergence. Maybe what I'm saying is, if a pipe is very big at the initial stage and the pipe size will be reduced for certain time, and after that the same pipe size will be coming. So what about the flow in the sense? The restrictions, before restriction, what about the pressure, velocity and area which will be same to the whatever the pressure and velocity and area which is after the restrictions. What Bernoulli's theorem says that both pressure, area and velocity, the component which will be equal to the pressure, velocity and area which will be in the next after the restriction. And these are the types of venturimeters which is available in the market. Horizontal, which can be fixed directly, which is the most used thing in the all industries. An inclined venturimeter is there. If your flow pipe is inclined, that is for 30 degree or 40 degree, if you are facing the pipe in industries, you can use some inclined venturimeter. And some vertical venturimeter is also available, that when you see some oven or any Milma or any milk industries where your pipes will be going in the top. Okay, in the condenser, your pipe input will be coming in the top. So that time, if you want to measure the flows, if you want to fix vertical venturimeter, you have to fix that. Okay, so for measuring the horizontal flow, you can use some horizontal venturimeter. For measuring some vertical flow in any industry, you can use some vertical venturimeters. Okay, and basic venturimeter types is there, and in between we have some meters is that when venturimeter is placed in a pipe carrying the fluid whose flow rate is to be measured, what we have to measure is the pressure drop across the entrance and after the convergence we have to measure. Okay, so here what we are relating is we are relating the pressure with flow. Whatever the pressure changes, the automatically the flow will also change. So here what we are going to see is if pressure is directly proportional to your flow. We are not measuring the flow directly. We are measuring pressure in terms of flow. Okay. And this is the operation. In first point, the fluid whose flow rate is to be measured enters the entry section. First, it is entering in the entry section, and next it is entering to the converging section. The fluid flow into the converging section, where the pressure keeps on reducing because you are reducing the area of the pipe. Okay, when you are reducing the area of the pipe, the pressure is also decreasing because you are making the pipe into very small. So automatically the pressure is also very minimum. Then after that, it will go for some extent. Then after that, it will go to its original position. Then once again, the pressure will be increasing based on the pipe sizes. So there will be some pressure drop as well as pressure gain. Okay, the two terms will be going on. And the main application where we are measuring or where we are using the venturimeter is when we need high pressure measurement. Okay, like continuous flow will be there in many oil and gas industries where all the liquids will be flowing 24 hours. That time, if you want to measure high pressure, you can use the venturimeter. And it can be used for water, gas, any solids or any dirty liquids like in most of the cement industry, the liquid itself, it makes dirty. Okay, if you want to measure that dirty liquids also, you can use some venturimeters. And it measures high flow rates in pipes having diameters in a few meters. Say for example, you can, if you want to measure a continuous monitoring of your flow, you can use this venturimeter for these purposes. Okay. So these are about the basics of venturimeter, and the main advantage is there is no pressure loss in between from starting to ending, and the construction is very simple and it can adapt for any flow measurement. Okay, for it can measure for very large pipes also. If a diameter is like 100 or 200 meters, you can measure the same. We can measure using a single venturimeter. And nowadays all the digital equipments comes into picture. Okay, that's why it has some, the accuracy problem will be there because venturimeter is used in olden days where the accuracy is very less. So when compared to the digital devices nowadays, we are not supposed to use this venturimeter nowadays, but everything is coming under digital side, and it is having some upstream disturbances is also there. Say for example, upstream disturbances in the sense, if any continuous slurries or continuous unwanted particles are coming into the flow lines, then automatically your reading, the strength will be very less. So we are not using for the nowadays. Previously there is no other option, we have to go for only venturimeter. But nowadays in flow measurement there are various types of meters are available in digital mode itself. We can easily use that. Okay, as a basic, venturimeter is a basic flow measurement device which can be used everywhere. Okay, and the next thing I am going to say is about pitot tubes. Okay, so if you want to make some fluid flow, so whatever it is, if you want to make some fluid flow measurement, we are going for a pitot tube. Okay, so how we are measuring in a pitot tube? So when a solid body is held centrally and stationary in a pipeline, due to the presence of the body, say for example, I'll say one example, there is one pipe. In that pipe, the liquid is going continuously, but if you give some disturbances in the pipe, say for example, if you putting some solids in the pipe, what about the flow? Whether the flow will decrease or increase? Initially the pipeline, the flow is going good. When you introduce some disturbances like some objects, okay, directly into that flow line, what will be that? Whether the flow will decrease or increase? Are you able to follow this? Or else I have to go slow. Any feedbacks can be shared. If you want to make me slow, I'll slow. But the topic is very vast. That's why we are moving very fast.
No, sir, it's okay.
Okay, fine. So the thing is that the fluid is approaching the object, starting its losing its velocity directly in front of the body. So the velocity for that corresponding point will be zero. That point is called a stagnation point. So the stagnation point is very important in pitot tube, and this is the construction of pitot tube. So the construction is nothing but it has some tube with 3.125 mm to 6.35 mm diameter pointing towards this fluid. So first one is in your diagram, this one is normal flow pipe. This L shaped, this L shape is called as pitot tube. Okay, so whenever there is one air flow will be there, the static pressure will be forming in this area and it will be matching with the upstream pressures. So for measuring any stagnation pressure, we can use for pitot tubes. And the common materials which the pitot tube is having is usually they will use some metals for using that, and fluid flow velocity for the upstream probes is reduced to zeros, and for that they will put one corresponding hole in that in the sides of the probe to sense the static pressure. And the total pressure developed at the point where the flow is stagnated is assumed to occur. And mainly in pitot tube, to obtain with this, it is necessary to move the tube back and forth across the stream. Say for example, if you want to measure the pitot tube, by using the pitot tube, you have to make the pitot tube top to bottom approach. You have to make one velocity in the top, and you have to insert that pitot tube into your pipe, and you have to measure one more reading, and you have to calculate the average between the two readings. So when we use the pitot tube, so we have to take so much readings. So you have to take 2 or 3 readings for measuring the corresponding flow. And finding those 2 or 3 readings, you have to find the average of those readings and you can get the final value. And mainly the advantages is like no pressure loss will be there, and the design will be very easy, and it can adapt any type of pipes and ducts. And the disadvantages, it can be not suitable, like previous one can be suitable for dirty environment, but this pitot tube, since it is used in two manner, top wise and bottom wise, it is not suitable for dirty environments, and it is sensitive to upstream disturbances. So whenever there is a disturbance comes, this pitot tube will not work. And mainly these are all the application which is coming in the liquid flows, open channel pipe, air flow, ducts, sacks, everywhere these all the components will be used. Okay, and next comes the flow nozzle. So before that, any doubt in that you can ask. Anyone having any doubt in venturi meter and pitot tube, you can ask. So we should not go very fast. So we have one more day, right? So you can ask any basic doubts on measurement or any up to now. Is it okay? Shall we move?
Yes, sir.
Yes.
Yes, sir.
Yes, thank you. So the thing is that whatever the measurement which I stated already, so before entering into any measurement, you must know the basics of measurement and what is the need for measurement. Okay, and the thing is that in any of the measurement, the error plays an important role for any measurement. Okay, when you measure manually or anything, before that more errors will be there. Now all the equipments or all the components will be made into automatic, so nowadays the errors will be very less when compared to the previous ones. Okay, so whenever going for any sensor type of equipments which comes under normal markets, so we are thinking about accuracy and the response, the fast response. So previously we have used for some normal mobile phones which we don't have internet facility at all, but nowadays smartphones coming into market, nowadays everything we can see within a fraction of seconds. If you want to open Google or if you want to open the internet, it is very easy and it is very cheap also. Previously, before 10 years or 15 years, what about the internet usage of India? Have you know that? In one article, they were mentioned before 15 years, the usage is only 13%. In India, the internet usage is only 13%. Now, the same statistics if you take now, what is the percentage you are expecting internet usage in India? Mostly 90% of the people are using nowadays internet. Okay, because everybody is having the smartphones, all the things comes into picture, so everything is like digitalization. So all the digitalization, whatever it may be, it makes some measurement and it makes some automation. So before entering into that, we have to touch some application side also. Not only this theoretical view, we can talk in application side also. So before that, we have to know some basics about automation. Okay, can anyone say what is automation?
Automation means something that works by its own.
Okay, what is the need for automation?
When some danger situation, when people are restricted to some area and we need to check on something, so we can
Okay,
use this type of applications
so
too.
you're telling about robots, right? So
Yeah.
if we cannot enter into that place, the robots can go and it will do that. And me, that's good. Okay. So the thing is that why we are going for automation is it will reduce the manual work. That is both advantage and disadvantages. Nowadays, most of the people are jobless because of those machines only. Previously, in every company, we have 100 or 150 employees to do the machine work. But nowadays, machine itself is doing the work. 100 people work will be done by one programmable logic controller. It will program automatically, and that too nowadays all artificial intelligence comes into market. Since you are computer science people, you familiar with the word artificial intelligence. So that is the talk of the day. Okay, nowadays artificial intelligence comes into market where the system itself thinking like human being. It will adapt the situation. Okay, initially we have to program and we have to execute it. If any problems is coming, we have to solve it. But nowadays the system itself debugging the problem and the system itself making its own solution. Okay, so nowadays automation plays an important role. So be an idea about in automation also. If you have free time, see some automation videos so that in interviews or any exam point of view it will be useful for you. And the next thing is our flow nozzle. So flow nozzle is similar like our previous one, where it is like a nozzle type. It has three types: holding ring, flashed flow nozzle, and weld-in connections. So mainly where we are using the nozzles. Nozzle is nothing but in opening in any flow pipes, it will be in the end type. Okay, it is like a corner tape and flange tape. In technical terms, they are telling like that. But in general manner, what I'm saying is when the pipe is at the end point, okay, whenever the liquid flows out, coming out, that time we are using some flapper nozzle system. Okay, flapper nozzle is nothing but to open or close the flow of the liquid, but you can control the flow by using the flapper nozzle systems, because about the openings, how much pipe you are using. So say for a real time example is when you have a water tap, if you open 50 percentage, only partial of the water will come. If you open 75 percentage, some 70 percentage of the water will come. If you open fully, all the waters which is present in the container or a tank will come out. So likewise, we have some nozzles. Then the nozzles also we have some ranges: 50 percentage, 75 percentage, and 100 percentage. Whenever if you want to use to control the flow of the liquid, you can use some nozzles also. Okay, that nozzles is always called as flapper nozzle systems. Okay, so the next thing is according to the corner tape and flanger tape. Okay, okay. The next one is advantages. So, what is the advantages between these flapper nozzle system is the installation of this flapper nozzle system is very easy when compared to the venturimeter, because venturimeter requires more piping arrangement. As in construction, we have seen that inlet one pipe will be there, outlet one pipe will be there. If you want to measure pressure between inlet and outlet, we have two different setups. For inlet, a separate setup will be needed. For outlet, we require separate setup. But in the case of flapper nozzle system, only one setup is required. So installation is very easy and it is very cheap. Okay, and it has very compact system, because flapper nozzle system can be carried easily from one place to another place. It can easily, we can carry this. And but in venturimeter and all, we cannot carry easily by hand. And some disadvantages is also there. Whenever there is a component, some advantage will be there, surely some disadvantage will be there. So the pressure recovery is very low, and the maintenance cost is very high. Since the component is very small, if any problem occurs, we have to throw the component and we have to buy the new one. So the installation, that maintenance cost will be very high. Okay, so these are all the disadvantages between that. And application is, if you want to measure the flow rates of the liquid, and where some suspended solids have the settling properties. Settling properties nothing but it will be settling in the pipes as usual. So we have to remove that, and we have to use that also. And next comes the rotameter. I think I have time today. Sir, I have time today now. Yes, thank you, sir. So I'll finish with this topic today. So next comes the rotameter. So rotameter is also a flow measuring device. So whatever we are studying today is all coming under flow measuring device. So rotameter consists of a tapered tube, and it is made up of glass. You can see in the diagram. So there will be one glass arrangement will be there. In that glass arrangement, in between some metal is there, metal or aluminum is there. So that is for the float. That is called as float. If any flow is coming from top to bottom, this float will go from bottom to top based on the flow. Okay, when the flow is very high, say for example in this pipe, in the bottom pipe, when the flow is very high, so surely the velocity will be very high, so it will lift the float to top to bottom position, and in between we are having some scale is there. So in the scale we can measure the float position, and when we measuring, the top edge of the float should be measured. We should not measure this bottom edge in the measurement. We should use the top edge for measuring. Okay, so the rotameter is mainly meant for the straight pipes. It cannot be used for horizontal or vertical. It cannot be for the cross-sectional pipes. It can be used for the straight pipes where we can measure the flow easily. Okay, so based on the movement of the float from bottom to top, so bottom to top we can use that. Okay, and as well as the rotameter has the same application, which will be used to measure the flow rates of the liquids discharged into the atmosphere, and usually in the situation where the solids have the property of settings, all the flow meters comes into the same thing only. And the rotameter requires no external power. The thing is that in other venturimeter or orifice meter, we require some external power supply, but in rotameter, which will be work in the physical property. Okay, the physical property in the sense it will go automatically with no external power. Okay, and rotameter is like based on the movement of water from bottom to top, the float will go automatically. Okay, and up to now I can finish today's session. Another 5 minutes is for your queries and thing. In the next topic we will cover in the next class. Okay, so any doubts related to that you can ask, or any other so up to now
So
yes, tell me.
you said rotameter is only for straight taps. So
Yes,
what will
yes,
happen if the tap is a little curved or it has some zigzag things?
I cannot hear you. Can you repeat this?
Rotameter is only for straight tube, straight pipes.
Vertical.
If it has a C shape or other shapes, what will we use?
Yeah, we can use, if you want to make some circular path, some orifice meter will be available. Okay, some other device is there for measuring that. And venturimeter also we have 3 different types now. If you want your flow will be vertical or inclined manner, we can go for venturimeter. The mainly thing is rotameter is for the horizontal purpose, vertical purpose, to measure the vertical flow. And that too we are not using any electrical power supply now. So it will be automatically flowing throughout the pressure. Okay,
Okay.
And if possible, I'll send you some automation videos related to that. End of the session, if coordinator, I'll get the some number from that, and we have some certain videos, animation videos related to flow measurement. I'll share with you people. Once you see the videos of that, real-time videos, when we start teaching this theoretical manner, I think 50% of the people can know. Okay, but when you see the animated video, real-time, how they are measuring the flow and how the turbulent flow will be there. Some interesting videos will be available. If possible, at the end of this FTP, we will able to share those videos also. When you have free time, you can see those videos so that you can get more information. Okay, and be in touch with our college faculties, since we have direct tie-up with many industries. So we have certain setups in our college also. If possible, we can guide you in certain ways. Okay, and probably in the next class, I mean tomorrow, I will go with the remaining topics like some other flow meters and what are the main applications of flow meters, and finally electromagnetic flow meters, and 2 or 3 4 topics is left out that will be covered tomorrow. Okay,
Okay, sir. Thank you.
thank you for
Okay, sir. Thank you.
Yes, thank
Any
you.
other queries, students? If you have any queries, please ask. Okay, I think the session is very clear. So thank you once again, Jayakannan sir, for sharing your valuable time with us.
Thank you, ma'am.
Thank you so much.
Thank you, ma'am. Thank you, ma'am. See you tomorrow, ma'am. Thank you.
Okay, sir. If you have any links